students, once again welcome back for chemistry online class. As you know that in chemistry we have already started chapter 9, that is the story of compound ammonia gas. Further timing we'll stop this chapter and we'll begin new chapter, that is chapter 5, mole concept and stoichiometry. From this chapter we'll discuss about the reduced syllabus only. From this chapter we'll discuss about relative vapor density and the relationship between vapor density and the molecular weight. Next, deduction of empirical and molecular formula of the compound from the percentage composition of a compound and the masses of combining elements. Today I would like to explain you relative vapor density and the relationship between vapor density and the molecular weight or molecular mass of the substance. The first one, relative vapor density. Relative vapor density is the ratio of the mass of certain volume of the gas or vapor to the mass of same volume of hydrogen. Here, relative vapor density is the ratio of the mass of certain volume of the gas or vapor to the mass of same volume of hydrogen gas. Now say next, what is the relationship molecular mass or molecular weight of the substance and vapor density? Here the molecular mass or the molecular weight of the substance is equal to twice its vapor density, and this proof is not required. Still I am going to explain about this proof. Here relative vapor density is the ratio of the mass of certain volume of the gas or vapor to the mass of same volume of hydrogen gas. Now next step, by applying Avogadro's law. Avogadro's law you have not done. Here Avogadro's law states that equal volumes of all the gases under similar condition of temperature and pressure contain same number of molecules. Here equal volumes of all the gases, if the same temperature and pressure, they will contain same number of molecules. Here relative vapor density, here mass of certain volume of the gas, here volume is substituted by molecule. Here mass of one molecule of the gas to the mass of one molecule of hydrogen. Here, by applying Avogadro's law, relative vapor density is equals to mass of one volume of the gas or vapor to the mass of one volume of, one molecule of hydrogen gas. By applying Avogadro's law, relative vapor density is defined as mass of one molecule of the gas or vapor to the mass of one molecule of hydrogen. You know hydrogen is a diatomic molecule. Its molecule is made of two atoms. Now here relative vapor density, mass of one molecule of the gas over mass of one molecule of hydrogen. One molecule of hydrogen contains two atoms. Hydrogen is a diatomic molecule. Your molecule is substituted by two atoms of hydrogen. Now next step, if both relative both sides, if we multiply by 2, here, if both the side is multiplied by 2 into RVD, relative vapor density, this side 2 and this side 2. Here mass of one molecule of the gas over mass of one molecule of hydrogen is multiplied by 2. This 2 cancel. Here 1. So here 2 into VD. 2 into VD. Here twice vapor density here relative molecular mass of the substance or relative molecular weight of the substance is equal to mass of one molecule of the gas over mass of one atom of hydrogen. See here, relative molecular mass or weight is the relative molecular mass is the ratio of mass of one molecule of the gas to the mass of one atom of hydrogen. Here, therefore, relative molecular mass is equal to twice its vapor density. For you, this proof is not required. Just you have to learn what is the relationship between molecular mass and vapor density. Here the molecular mass or molecular weight of a substance is equal to twice its vapor density. Now we have ICSE question. Here question number 2. ICSE 2014, page number 101. I'll read out the question. Here question number 2. A compound made up of two elements X and Y has an empirical formula X2Y. If the atomic weight of X is 10 and that of Y is 5 and the compound as a vapor density is 25, find its molecular formula. First of all, I would like to explain you what is the difference between empirical formula and molecular formula. Empirical formula is the simplest formula of the compound which does not show the actual number of atoms present in one molecule of a compound. Whereas molecular formula is the symbolic representation of the compound which show the actual number of atoms of each element present in one molecule of a compound. And the molecular weight of the substance is always obtained by adding the atomic weight of each element present in one molecule of a compound. Now here in this question, here empirical formula is given X2Y. So first of all we will write solution. Empirical formula. Empirical formula of the compound. What is the empirical formula is given here? X2Y. X2Y. Then second step we will find out the empirical formula weight. Empirical formula weight. Here X2Y. What is the atomic weight X of X? 10. So 2 atoms of X. 10 into 2 plus 1 atom of Y. What is the atomic weight of Y? 5. So 5 into 1. So 10 to the 20 plus 5 on the 5, 25. This is 25. Now here empirical formula weight of the compound is 25. Now Vd has given. What is Vd? Since Vd is equals to how much? Vd has given how much? Vd has given 25. Now here what is the relationship between molecular weight and the vapor density? Molecular weight of the substance is equals to twice its vapor density. So relative molecular mass of the substance is equals to 2 into Vd. 2 into Vd. Here relative molecular mass, vapor density is 25. 2 into 25. This will be 50. Molecular mass of the compound is equals to 50. Now next step here molecular formula or molecular mass, relative molecular mass of the substance is equals to empirical formula weight into N. First of all we will find out the value of N. What is the molecular 50, we'll write 50 here, is equals to 2, empirical formula weight is how much? 25 into n. Now we'll find out the value of n. And therefore n equals to 50 over 25. So 2 times. So n equals to 2. Now next step, we'll write the molecular formula. Molecular formula equals to empirical formula into n. Now we are finding the molecular formula. So what is the empirical formula? X to y. So x to y. Now what is the value of n? Value of n is 2. So multiply this. X 2 2s are 4. X4 y2. The molecular formula of the compound is X4 y2. This is how we can find out the empirical formula and molecular formula of the compound from the percentage composition of the element or masses of the element. Dear children, here we are come to the end of today's online class. Thank you very much.